how to find K value for given gain margin and phase margin. So it is some kind of a design where we are trying to find the gain of the system for a specified gain margin and specified phase margin. And we look at the step. And this method is an analytical method. Graphically we can get using the polar plot and also using the bode plot. Now analytically we have steps. The first one is, let us say, how to find K value for given gain margin. So take the GH of S transfer function. This transfer function will have gain K into other terms. Now write GH of J omega by substituting S is equal to J omega. That will be the sinusoidal transfer function. Then write the magnitude expression and phase angle expression of the GH of J omega. And the next step is, we equate the phase angle to minus 180 degrees and find out what is omega, which is omega Pc. So omega Pc calculation is same for this case and also in the original to find the gain margin and phase margin. So same method we can follow here to find the omega Pc. So once you have the omega Pc, then substitute in the magnitude expression. Then you will get the Mpc, but Mpc is not the value. We have Mpc in terms of the gain K. Finally, we have already gain margin specified. So gain margin specified is 20 log minus 20 log Mpc. So gain margin specified is known to us minus 20 log Mpc. In Mpc we have K. Therefore we can solve for it. We can find out the gain K. So at that particular value of gain, the system will give us the specified gain margin. Now, what will be the K value for a specified phase margin? So in this case, GH of S will be given in terms of K, and again substitute S is equal to J omega, get sinusoidal transfer function, write the magnitude and phase angle expressions. The next step is, we have already phase margin specified. So find out what is the phi GC required for that particular specified phase margin. Then the phi GC or the phi GC required is, we can write it as a phase margin specified minus 180 degrees. So then we can get what is the phi GC required. The next step is, phase angle expression is available, equate the phase angle expression to phi GC required. Then solve for omega. So this omega is omega GC. Once you have the omega GC, substitute in the magnitude is equal to 1. When you substitute magnitude is equal to 1, because in magnitude we already K, and at omega value we are substituting omega GC. When you solve for it, you will be getting K value. At this K value, the particular system will give us whatever the phase margin is specified. To understand these two methods, let us take one example. The problem statement goes like this. Consider a control system whose open loop transfer function is given by GH of S is equal to K by S into S plus 2 into S plus 4. First part of the work. Find K value such that system will have the gain margin of 14 dB. Second part B. Find the K value such that the system will have the phase margin of 30 degrees. So in this problem, the transfer function is given and it is in terms of K. Then we need to find K value both the cases. The first case is, if at all you want to have the gain margin of 14 dB, what will be the K value? It is the gain adjustment in the system. So usually the gain will be the amplifier gain. It is like a knob, we can adjust it. So that adjustment for the required, because for one particular application the gain margin may be 14 dB, and another application it may be 20 dB, and sometimes it may be just 10 dB. So according to the requirement, we need to adjust the knob, which is the open loop gain K. That gain we need to find. The first case, we require the gain margin of 14 dB. Second case, we require the phase margin of 30 dB. We already seen the steps. Let us see how to find the first part. So before that, let us take the transfer function GH of S, that is K by S into S plus 2 into S plus 4. Substitute S is equal to J omega, get GH of S, which is I have numerator K divided by J omega, 2 plus J omega, 4 plus J omega. Write the magnitude expression. M is equal to, we have numerator K as it is, denominator is omega, under root of 4 plus j omega, under root of 16 plus 4 plus omega square, under root of 16 plus omega square. So magnitude, the phase angle is, numerator I have K, therefore the phase angle is 0 only. For denominator, for j omega it is minus 90, so phase angle is minus 90, minus tan inverse omega by 2, minus tan inverse omega by 4, or you can write minus 90 minus tan inverse 0.5 omega minus tan inverse 0.25 omega. So magnitude and phase angle expressions are ready now. So the first part let us take. The first part is, we need to find K value for specified gain margin of 14 dB. So I'll take the phase angle expression and equate it to minus 180 degrees. So if you do that, we have minus 90 minus tan inverse 0.5 omega minus tan inverse 0.2 omega is equal to minus 180 degrees. I can cancel all minus, I can take this 90 degrees other side. So I will be getting it as a tan inverse of 0.5 omega plus tan inverse of 0.25 omega is equal to 90 degrees. Then you just apply both sides, tan on both sides. When you apply right side, that will be infinity. When you apply here, you will be getting tan A plus B. So A is 0.5 plus 0.25 divided by, we have 1 minus 0.125 omega square is infinity. You reverse it, then you will be getting 1 minus 0.125 omega square is 0. You will be getting the omega value as root 8. So under root 8 will be the omega Pc. Now this omega Pc is irrespective of the K value, because to find omega Pc we need only phase angle expression. For any phase angle expression, if you have gain, for that gain phase angle will be 0 degrees only. So omega Pc never depends on the K value. That is the reason why when we look at the bode diagram, if you want to have the gain adjustment, if you adjust the magnitude plot, there will be change in the only omega gc, but there is no change in the omega Pc. Omega Pc is remains same only even if you change the gain value. That is why here also when you equate to minus 180 degrees, you will be getting omega Pc very easily. Now coming to find the Mpc value, and to find Mpc value you just find out omega Pc in the expression of magnitude. So K by omega Pc square root of 4 plus omega Pc square under root of 16 plus omega Pc square. Then I can find out what will be the Mpc. So when you get this is going to be 0.02 K. So I have Mpc in terms of K. So the final step, we know what is gain margin specified, that is 14 dB is equal to, so minus 20 log Mpc. What is Mpc here? 0.02 K. When you substitute, then you will be getting what will be the K value. The K value is going to be 10, which means in the transfer function, if you adjust the K value to 10, then that particular system will give us the gain margin of 14 dB, which is required to us. Similarly, the second part of the problem. In the second part, we need to find K value such that the phase margin is going to be 30 degrees. We know the steps. So first of all, we have to find what is the phi GC required. The phi GC required is phase margin specified minus 180 degrees. Specified is going to be 30 degrees. 30 minus 180 is 150. Therefore, phi GC required is minus 150 degrees. Now, equate the phase angle expression to phi GC required. What is phase angle expression? We have already minus 90 minus tan inverse 0.5 omega minus tan inverse 0.25 omega, that is equal to minus 150. Now we can solve this. So we can cancel all minus. Then we will be getting it as minus 150. I have already 90, that will be 60. So then apply the tan on both sides. When you apply tan on both sides, we have tan 60 here, and here we have 0.5 omega gc plus 0.25 omega gc, under root we have 1 minus 0.125 omega gc square. So when you solve this, you will be getting omega gc two values, one is a positive, other one is negative. Generally frequency we should take always positive value, so that omega gc is going to be 1.585. So usually when you are trying to find the phase margin, we equate the magnitude to 1, then we find the gain margin, gain crossover frequency. But in this case, already we have the required phase margin, so that I am trying to get what will be the phi GC for corresponding omega GC. So we are doing the reverse way, so we got omega GC as 1.585. Then what I need to do, I need to equate magnitude to 1, whereas to find the phase margin, this will be the first step. In this case, this will be the last step, where we are equating magnitude to 1. So at omega is omega GC. When we know that in magnitude there is a K constant. So you substitute omega GC here, 1.585 in this expression magnitude, and we are equating to 1, and you will be getting the K value as 17. So what does it mean here? When you adjust the gain of the system to 17, then the phase margin of the system will have 30 degrees.